Okay, here are the steps for naming alkanes. So first, identify the root. So you want to find the longest continuous chain. Okay, and it can be bent. So like sometimes all of a sudden you'll have a chain coming off here. That can be part of your longest continuous chain. The worst habit we kind of get into is just whatever's in the horizontal here, we just make that our longest continuous chain. But sometimes it gets way longer. If this branch came off this carbon, now that would be part of our longest chain. Okay, so find the longest continuous chain, which then tells us the root name of that chain. So in this case, there's 6 carbons, so our root name is hex. Okay, hex for 6. Identify the suffix. Okay, so again, these are all single bonds. Okay, so our suffix is ane, because this is an alkane. So like our root is hex, our suffix is ane, so this would be hexane. Okay. Now we want to identify the prefix. So the prefix indicates the position of the branches on the main chain by assigning numbers to the carbon on the main chain. So here's our main chain. We have the branch coming off here and a branch coming off here. Okay, so we want to assign numbers so that they're the lowest for our main chain. So for this one, like if I assign this carbon as carbon number 1, then 2, 3, 4, 5, 6, then my branches would be coming off the number 2 and the number 3 carbon. If I went from the other side of my main chain, like and I went 1, 2, 3, 4, 5, also now this would be the 4 and 5 carbons. I want to have them so that they're lowest possible number. Okay, and so 2 and 3 is a lot lower than 4 and 5. Okay, and if you ever aren't sure, add the numbers up, whichever gives you a lower value, then those are the numbers you'd use. Because sometimes you'll have like 3, 3, 4 or 2, 2, 5. Okay, if you aren't sure which one's like overall lower, add them all up and see which one gives you a lower number. Okay, and so the prefix, so once the numbering begins at the lowest, or the side that give us the lowest possible numbers, now the side groups are called substituent groups, okay, or we just call them side groups more commonly. Okay, the side groups on the alkanes are basically alkanes that are missing a hydrogen atom, so we call them alkyl groups. Okay, they're named by using the root name that we would use for the main chain, but instead of the suffix ane, because they're alkyl groups, we use the YL. So like this one here, there's 1 carbon, so it becomes meth, would be our kind of main or root part for that. And then we add the YL, so we get a methyl group. Okay, if we have 2 carbons like we do here, that's an ethyl group. Okay, the next, propyl, butyl, usually you don't get much longer than that. Okay, and make sure, like, if you have like a butyl, make sure it's not part of the main chain. Okay, because sometimes it branches off and all of a sudden we got a butyl. Like in this case, this is 6 carbons. If it was a butyl group, then all of a sudden we'd have an 8 carbon main chain, and then this would be our side chain over here. Okay, so the first thing that we want to do, find a number of carbons on each side group. Find the root name for each side group. So we have a methyl group and an ethyl group. Okay, and then determine an alphabetical order of the side groups. So basically, ethyl is always going to be, or actually butyl would be first, then ethyl, then methyl, then propyl. Okay, they always go in alphabetical order. Okay, and that's only if there's more than one. If there's just one methyl group, you don't have to worry about it. And then you find the position of each side group. Okay, and so in this case, this would be in position 2 would be a methyl, in position 3, because when we number them, this is carbon 2, carbon 3. So this would be 3 ethyl, 2 methyl, hexane. And that's how we would name it. Okay, so we'll do some examples here. Okay, so there's, again, first step, find your longest chain. So, and like you can highlight it, like draw a circle around it, whatever you want to do. Then you want to number it. Again, starting like so you get the lowest numbers. So in this case, we know that we'll start over here. This would be 1, 2, 3. Okay, and so we have hexane. Since there's 2 branches, Okay, we start on the right end. Okay, and now we name our branches, okay, from the lowest number. One thing to note is we have 2 methyl groups here. So because we have 2, we call it dimethyl. Di meaning 2. Okay, so this, in this case, the name of this compound is 2,3-dimethyl hexane. Okay, for these examples here, okay, it kind of goes through the steps. Again, like this stuff is out of your textbook. A lot of these steps you can find. Okay, I'll just kind of go through it with you. So we have a 5-carbon chain here. That's our main chain. Okay, we have 3 methyl groups coming off of it. It doesn't really matter because it's symmetrical which side you start with as far as numbering, like 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. We're still going to get, either way, 2, 3, 4 trimethyl pentane. Okay, and for this one, okay, we have to count out like what's our longest chain. So if we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So our longest chain is a 6-carbon chain. Okay, so now looking at that 6-carbon chain, we want to start our numbering. So if we start here, it'd be 1, 2, 3, 4. If we start here, it'd be 1, 2, 3, 4. So either way, we're gonna we'll have our numbers 3 and 4. But since we kind of have like 2 branches coming off this one, to make our numbers, like instead of having 3, 4, 4, we'd rather have 3, 3, 4 as our numbering. So we're going to start our numbering from this side. Okay, and so we have our main chain is hexane. Then we look at our groups. We have an ethyl group coming off the 3rd carbon. And then we have 2 methyl groups, one coming off the 3rd carbon, one coming off the 4th carbon. Okay, and so for naming this, it'd be 3-ethyl, 3,4-dimethyl hexane. Okay, so some more practice. Again, these ones are in your textbook. Okay, you can go through. It kind of shows you it has the numbering. Okay, so like this one would be 3-ethyl, 2-methyl hexane. Okay, and so like go through, read over these. If you need any more examples, I'm happy to have a lot that I can do. I can do them out of your text or out of your assignment too. Okay, and some learning tips. These kind of just help for like some of those that you aren't sure about. Okay, or like the order or like least complexity, things like that. Okay. One thing to note here is like when we're doing alphabetical order, we only worry about like the main part. So the ethyl and methyl, the di, when we put that in, doesn't matter. We only pay attention to the M, like the main part of the group. Okay, and so even though there's more than one, that di or ethyl stays before dimethyl. Okay, now if we want to draw our alkanes, okay, we use the same system, okay, but now we're just going to draw out the straight chain. So like we'll never have kind of branches. I guess if you were in a room, maybe you'd do that. But again, I'm going to try and draw it just using the computer here. We'll see how it looks. Okay, so you draw a straight chain containing a number of carbon atoms. So represented by the name of parent chain, and then number the carbon atoms from left to right. So we start here. We look at our parent chain right here, pent. Okay, pent means 5. So we just draw our 5-carbon chain. Okay. That's a nice C there. All right, we got 5-carbon chain. Okay, so that's where we start. We draw our pent 5-carbon chain, left to right. Okay, now we look at our side groups. Okay, so we have 3-ethyl. So coming off the 3rd carbon, we have 2 more carbons coming off of that as a branch. Okay, and then off the 2nd and 4th carbon, and like when I do my numbering, I always go left to right because that's the way we read, so I just always do it that way. Okay, and it's just easier to see. So coming off the second and fourth carbon, we have methyl groups. Okay, so we have 3-ethyl, 2,4-dimethyl pentane. So we have our pentane and our methyl groups and our ethyl groups. Okay, now we just fill in the proper number of H's. So each carbon needs to be bonded 4 times. So if it already has 1 bond, I have to add 3 H's. Okay, and this is really what takes so long when you're drawing these structural formulas, is filling in these H's. And that's why like the condensed is a lot quicker. Okay, and one thing, like when I'm marking it, the first thing I look for is there 4 carbon or 4 bonds around each carbon. That's the easiest way to kind of look and see if you're doing it right. Okay, I'm not going to draw all these in, but there'll be another H here, there'll be 3 H's here, 1 H here, 3 here, and 3 here. Okay, and so like this is kind of, this breaks it into the steps that you would do. I did it all just right up here. Okay, and so we draw a straight chain. Okay, we add our branches. That's what we did second. And then we add enough hydrogens to kind of fill it all in. Okay. Okay, so some more practice. Okay, a couple things, like, so for this one, it doesn't give us any numbers. When it doesn't give us any numbers, that means like there's only one place those branches can go in. So like if I was drawing tetramethylbutane, so I'd start with my 4 carbon. There's my 4 carbon for butane. Okay, tetramethyl, no branches can ever come off the 2 end carbons, because if they did, now we'd have pentane, right? So if I added a C over here, now I have a 5 carbon chain, it's pentane. So the only places you can come off of them is these 2 middle C's. And so since it's tetramethyl, we have our 4 methyl groups coming off these inside 2 carbons. Okay, that's the only place they can go. So that when you don't see a numbering, there's only one possible place they can go. Okay, and so yeah, this would be it, and then you'd fill in all your H's for that. Okay, again, like if you want me to do more examples, I don't want to write them out. It takes me forever to do it on the computer here, but I can do them by hand and just make a short video of that if you would like. Whoops. Okay, we'll stop there, and hopefully that helps you knowing how to do the alkane.